In the next one, because I think from our first class till today's class, we talk many examples of how AI is changing our world, and we will also have some introduction in today's class. But we have already heard lots of the application or the real example. Maybe to catch up some of the theory-based lecture may be also interested for everyone. So I will only use several minutes to explain what is about the deep learning, because from last class we already explained that the artificial intelligence actually includes two parts. The first one is the deep learning, and the other one is the machine learning. For the deep learning, it's the more modern and the more complicated and the comprehensive algorithm nowadays. So we are going to talk about what is deep learning for a little bit while. So from this part one, I think we summarize 3 things you need to know about the deep learning. The first one is, how does deep learning attain such impressive result? Because we know that in the recent years, the artificial intelligence, for example, in image classification or voice recognition or in the autopilots, give us lots of the successful experiments that do not have in the past. So recent advances in deep learning have improved to achieve recognition accuracy where outperforms humans. Actually, this is the same. Actually, because deep learning has 2 main reasons that it has only recently become useful. Okay, because it requires large amount of label data, and the second is that requires substantial computing powers. Before 2010, I think the human beings semiconductor technology is still was still growing. Maybe before 2010 or 2012. So at that time, the cost of the data storage in digital format is expensive. In other words, the computation speed or computational power of the computers in the past is not powerful enough too. So at this step, after 2015, I think the matureness of human beings semiconductor technology has achieved a very great performance. So nowadays we can use very low price to have large amount of the data storage, and we can also spend less money to have a great computation power. So as here, I want to show you a very personalized experiments. When I was around, I think maybe 15 years old, that's already now I'm 36 years old, so that's around 15 years before. 20 years. Okay, Annie remind me that I try to say that I'm a little bit younger, but Annie already captured. Annie already know what I'm going to for you. So just kidding. So maybe before 20 years ago, we need to spend around $1,500 to buy a computer in Taiwan, and the computation complexity or computation performance of the computer we bought in 20 years ago cannot outperform the computation power by our smartphone today. Nowadays, most of the smartphone only cost around maybe $500 to $700 per smartphone, and you can know that it's much more cheaper than the old personal computer in 20 years before. But the smartphone has better computation power in today than the traditional personal PC. So we can know that because the matureness of the semiconductor technology, so we can use less budget and less money to have very powerful computation power and efficient data storage. So it become a foundation for us to develop very successful deep learning in nowadays. And in next, we can see some examples of deep learning at work. So it can be used in many fields such as the automatic driving, aerospace and defense, medical research, industry, automation, and electronics. And how deep learning works, I think it's very important, and many audience wants to listen about this. First of all, we want to say that why we say the deep learning neural network has the terminology of learning. Actually, learning is a special capability of human beings. And the capabilities of learning actually matters to the structure of our brain and our neurons, or the theory in neurology. So basically, the deep learning and the machine learning sciences developed from the concept of biology and the neurology. And you can see that most deep learning methods use neural network architecture, refers to as deep neural network. They learn features from data without manual feature extraction. And it can create and train learning models from 3 types, such as the training from scratch, transfer learning, and the feature extraction. And from the architecture you see here, and this is a very, very brief and a simple architecture of a neural network. For a neural network, we have input layers, and the hidden layers, and the output layers. And all the nodes here are connected to each other. Then all of the neuron can have the output based on the input and the activation functions. And by the transmission of the signal to each stage, it can mimic the behavior of human or animals in our neuron. So basically, the concept or the fundamental architecture of the deep learning networks mimics from the simple neural architecture from the animals and the human beings. So that's why we say that the deep learning actually mimics about the function of human beings or animals, and we mimic our activity in neurology and transfer it into mathematics expression to let the computation process can mimic the behavior of a neuron or a neural network. So that's the originality of the deep learning, because it is deeply correlated to deep neural network. And the next one, because it's a topic that we talk about the deep learning. So from the previous lecture, I proposed 3 terminology. First, artificial intelligence, second, machine learning, and the third, deep learning. So actually, the deep learning and the machine learning are subset for artificial intelligence. And the most difference between machine learning and the deep learning is that machine learning use relevant features being manually extracted from image. Sometimes I think the image can say that it are data samples. Okay, so the machine learning use relevant features being manually extracted from image, but deep learnings don't. Deep learning algorithms scale with data, and the networks often continue to improve as the size of your data increase. And by choosing between machine learning and the deep learning, consider whether have a high performance GPU and lots of labeled data. So if your data has already been large scale labeled, and you have a large computation resources such as the high performance CPU, then you can try to use the deep learning algorithm, because it can automatically analyze the most reliable features, can help us to discriminate different classes, pattern, or image we want to discriminate. And for a traditional machine learning one, the designers needs to define what kind of features should be selected and input it to the classified and get the final result. So I think how the engagement in the feature extraction, if the engagement of the feature extraction rely on most automatically computation, I think it will be more relevant to deep learning fields. And if the features are mostly generated by human beings or defined by the designers, him or herself, that's more related to the machine learning. And the next one, we can see that what is deep learning and how it works. So from this simple structure, this is a very, very simple but essential architecture for the deep learning. And the deep learning is a machine learning technique and it mimics the works of the human brain. So it comes from the terminology so-called artificial neural network, ANN. And the input value pass through neurons that neurons delivers the output signal. And it can use many layers of nonlinear processing unit for the feature extraction and the transformation. So it's just like our neuron and neural and our neuron. For our neurons, actually it can be activate or deactivate based on the input or the firing strengths from other neurons. So the architecture and the behavior in animals or in human beings are quite similar to the mathematic operation of the artificial neural network here. Okay, and what happens inside the neuron? We know that if we use this example, this is the feed-forward neural network, and for the forward propagation, we have weights in each neuron, and we have transfer functions and the activation functions inside each neuron, and we can compare the output values to our expected results, then use the back propagation. Actually, it's the function of the back propagation very, very likes to the learning behaviors we have, but it comes from the theory of the mathematic optimization, and use the back propagation to use the errors in the output neurons to errors between the output neurons to the desired output, and back propagates the error to adjust all the weights and minimize the loss functions. So back propagation helps us to adjust the architecture and the weighting of all the artificial neural network. Then based on these kind of mathematic results or expression, we can have the capability to let our neural network can learn and have the satisfactory performance. And how does an artificial neural network learn? There are two approaches. First one is to tell neural network the input and the output, specially guided and the hard program approach, and the only need to create the network architecture to avoid entering all the rules. So we, to say it in short, we can use the parameter learning and the architecture adjustment for the learning capability for a neural network. And this is the network we already mentioned a little bit in the few slides before. It is the feed-forward neural network, and it contains input, output, and hidden layers. Only one direction is from either left-hand side to right-hand side, or from right to left. It is also okay, but generally we use the direction from left to right, and the application is in the data mining. Then, okay, so in the next, we're talking about some of the details in the architecture. So this is about the weighted sum, and it is very useful for us to develop the algorithm in a neural network, and we guys can learn lots about the computation progress of here. So for the weighted sum and the activation function, that is all the things we will use in the artificial neural network or the deep learning neural network. And for the details of this part, the class in next week will be discussed more in here. So in the activation function, it is more likely like the threshold function, but with the different types such as the sigmoid and the hyperbolic tangent function, hyperbolic tangent sigmoid function, or the rectifier function. So different kinds of activation function can be used in different kinds of classification tasks, because different kinds of classification tasks can be better fit based on different kinds of activation function. So how to choose an activation function is also a very, very important research issues when we do the research. So for the learning part, it is actually very complicated. So I just want to give you some concept that the learning part actually comes from the concept of the gradient descent, and it matters a lot about the calculus and the optimization theory. So here are the part we have in our learning gradient descent, such as batch gradient descent and so on. So for the detailed part of the gradient descent technology, I think the instructor in the coming week will have more detailed explanation on that. And for all the audience today, you are welcome to take the reference of all the optimization and the learning techniques, and just feel free to let me know if you have any question during your studies here. So finally, I think we can have some summary or some we can summary our learning gradient descent algorithm in different kinds of method. They have various capability and the performance in accuracy, update speed, memory usage, and the capability of online learning. So that's the brief discussion for my introduction in what is deep learning. So I hope you will like it. Yes. So next one, we will have some class activity here, right?
Right.
So,
I hear that you prepare some quiz for us.
Okay.
And can you show us how to get into the quiz section?
Okay, so now can we turn our monitor to Core Lab? Okay, so
can we invite students to answer the pop quiz questions?
yes, so can everyone come with me to enter your Core Lab and select the course of our today's course. And if you select the course content here, and it goes to the introduction to AI fundamentals and the real world examples here, and if we can go to the public， 是我已经有转过，我有投啊，有。Okay, so sorry. If you goes to here, if you press the course contents and it goes to today's class, it's the introduction to AI fundamentals and the real world application. Then please select the pop quiz. Okay, here. Then after the pop quiz, we can open all of our quizzes here. Okay, it is downloading the. It is downloading. Ooh, what's the matter? Okay, we have pop quiz 1 to 6. Of course, you are encouraged to answer all of them. But right now, since we are we wish we can have more and more interaction with the audience today. So I would like to open the quiz 2 in first and ask someone to answer for us in this quiz.
Okay, so we'll start from question 2.
Yeah. Okay, so since the internet here is still my web page browser is continues to download the quiz, can anyone in front of the screen who can already see the quizzes, would you please raise your hand? And I want to ask our TA to invite some student who already can see the quiz, and let's ask them to tell them what is the content of the quiz right now. For anyone who can see the quiz question, would you please raise your hand and tell us what is the question? Yeah, can anyone see the yep. One guy's already told us. what is not AI algorithm? This is the question. So can we have the option here? Okay. So the first one is the smart factory and the search engine. Third one is religious, and the fourth one is medical. Okay. So okay, I think this is another. This is yeah. Sorry, let me repeat it. Our quiz number 2. What field cannot apply AI algorithm based on our knowledge so far? I wrote this question. Please focus on which field cannot apply AI algorithm based on our knowledge right now. I mean right now. So that means it may be possible to being utilize the AI in the future, but that is not right now. So can anyone share me with your answer, and then maybe you can share with us why the AI cannot apply to the answer you want to answer us right now, and is it possible to be is it possible that AI can be utilized in the answer you select in the future, and what is your reason? Maybe you can tell us a little bit about that.
My name is Lavin from Thailand.
Hi, Lavin, nice to hear you.
Yes. So sorry because I joined to this course is late because I have problem with the Google Chrome because when I connect the the Google Chrome is report to me Java have problem. I ask in question in chat. Okay,
Yes.
but now in this your quiz in this question,
Yes.
religion is not apply AI algorithm based in our knowledge right now.
Yes. That's the correct answer.